let's have a chat about these specific type of equations, the quadratics. And it all comes down to one basic idea. If you've got two things that multiply together to give 0, one of them has got to be 0. Right? It's that unusual number of 0. No other number works like that. I mean, if I said you got two numbers that multiply together to give 1, it's not necessarily true that one of those numbers has to be 1. I mean, you could have a half times 2, or a third times 3. But 0. And that's why we always try to make them equal to 0, because here we can be definite. One of those factors has to be 0. So that's the idea behind quadratic equations. So if we can factorise this to two factors, binomials, remember, two terms. Let's see, multiplies together to give 18, adds together to give 9 is 6 and 3. Now, most people just jump to the answer. They don't actually write the line in, but theoretically what we're saying is, that means either x plus 6 is equal to 0 or x plus 3 is equal to 0, so therefore x is negative 6 or x is negative 3. I put this one in here because often people forget the x, and they just solve that one and go, x is negative a half. But there is the possibility of the other factor x as well. So of course there is a possibility that x could equal 0. So be careful there. Just because it's not a binomial doesn't mean it's not a part of the solution there. Okay. Sometimes they don't factorise, and that's where we come up with this beautiful quadratic formula, which saves us a bit of time. There it is. Probably one of the first really good formulas you learnt in maths. Negative b plus or minus the square root of b squared minus 4ac all over 2a. It's important to note. Let's solve this one. 2x squared plus 5x minus 4 is equal to 0. So there we go, we sub it in. 25, 37 is 57. 57, is 57 prime? I think 57 is prime, isn't it? Can't think of any factors. 19 is a factor? But 19 and 3 is not going to help us. We want a perfect square, don't we? So we'd leave that one with 57. Now, some people get a bit obsessive. That is the exact answer, of course. And split it up into two answers. You know, either the plus or the minus. That's fine. Just leave it all in one, of course. Unless we're going to use it for something else. If they ask us to approximate, okay, then we'll go to our calculator and whatever, say it was 2 decimal places, obviously we'd write it down like that. But in maths, we're about exactness. So if they don't ask me to approximate, I'm not going to waste time. I want the exact answer. This is not science, this is maths. Scientists, they're more interested in approximations than exactness, because they can't handle surds and things like that. They struggle, you know. Yeah, no, that's true. It's true. Haven't you noticed in science they always round things off? They can't have an exact answer. This is not good. Whereas mathematicians, we like exact. If we get something like this, make x the subject. Really, it's just solving a quadratic equation. That's all it really is. If x is the subject, we're thinking x is the pronumeral. Every other pronumeral we see there, we pretend like it's a constant. So in fact, it becomes the equation x squared plus 4x minus 3 plus y equals 0. And then I just bung it into the quadratic formula. And in this case, we have got a factor of 4 that we can pull out. And of course, square root of 4 is 2. And we can do some cancelling as well. And we get an answer. Well, cancelling of 2 as well, I said. There you go. X equals negative 2 plus or minus the square root of 7 plus y. What it's actually doing, because of course we talk about graphs now, y equals x squared plus 4x minus 3 of course would be a parabola. And so normally we write those things, well there's a parabola over there, as y equals. But if I was to make x the subject, what we've got basically are the two halves of the parabola. One is the left-hand side, the minus, and one is the right-hand side. And that's effectively what that formula's done. It's got us the equation of the two branches of the parabola. Okay, there's enough chatting for today.